Welcome to EDU Aero Classroom. In this tutorial, we will discuss some examples on combination. First example is evaluate 10C8. As we know that 10C8 will be equal to 10C2 because NCR is equal to NCn minus R. So applying this property over here we get this. Now apply the formula of combination which is n factorial divided by r factorial into n minus r factorial which will be equal to 10 factorial, r is 2 factorial and n minus r is 8 factorial. So we get 10 factorial is equal to 10 into 9 into 8 factorial divided by 2 factorial into 8 factorial. 8 factorial will be cancelled out by 8 factorial and 2 factorial will this come as so this is equal to 45. This is the required answer. Now let us see second example which is if NPR is equal to 720 and NCR is equal to 120, find R. As we know that NCR is equal to NPR divided by R factorial because NPR is equal to n factorial divided by n minus r factorial and NCR is equal to n factorial divided by r factorial into n minus r factorial. So we can say that NCR is equal to NPR divided by r factorial. Now putting the values 120 is equal to 720 by r factorial and r factorial will be equal to 720 by 120 which is equal to 6 and r factorial is equal to, as we know that 6 is the factorial of 3. So r factorial is equal to 3 factorial. Factorial will be cancelled out by factorial or r is equal to 3. So we get r is equal to 3. In this question it is given that if the ratio of 2nC3 is to nC3 is 11 is to 1 and we have to find the value of n. Now it is given that nC3 divided by nC3 is equal to 11 by 1. Now apply the formula of combination in the denominator and numerator we get 2n minus 3 factorial divided by n factorial divided by 3 factorial into n minus 3 factorial which is equal to 11 by 1. From here we get 2n factorial into 3 factorial into n minus 3 factorial divided by 3 factorial n factorial into 2n minus 3 factorial is equal to 11 minus 1. 3 factorial is cancelled by 3 factorial, n factorial is cancelled by n factorial. We get this term. Sorry, I did one mistake. We cannot cancel out n factorial by 2n factorial. So this is equal to 2n factorial n minus minus 3 factorial upon n factorial 2n minus 3 by factorial which is equal to 11 by 1. Now expanding this 2n factorial is equal to 2n into 2n minus 1 into 2n minus 2 into 2n minus 3 factorial divided into n minus 3 factorial divided by n factorial can be written as n into n minus 1 into n minus 2 into n minus 3 factorial into 2n minus 3 factorial which is equal to 11 by 1. Now 2n minus 3 factorial is cancelled by 2n minus 3 factorial and n minus 3 factorial is cancelled by n minus 3 factorial. So we get 2n, 2n minus 1, 2n minus 2 divided by n, n minus 1, n minus 2 is equal to 11 by 1. N will be cancelled out by n. Taking out 2 in this common, so we get n minus 1. So n minus 1 will be cancelled out by n minus 1. So remaining term will be 4 2n minus 1 divided by n minus 2 is equal to 11 by 1, which implies that 8n minus 4 is equal to 11n minus 22 which is equal to 3n is equal to 18 which implies that n is equal to 6 which is the required answer. In this example it is given that from a class of 32 students 4 are to be chosen for a competition. In how many ways can this be done? Since required number of ways will be 32 C4 because n is equal to 32, that is number of objects, that is number of students is 32, and 4 are to be chosen out of 32. So r is equal to 4. So replacing n by 32 and r is by 4, we get this. Now applying the formula of combination, we get 32 minus 4 is equal to 28 factorial. 32 factorial is equal to 32 into 31 into 30 into 29 into 28 factorial divided by 4 factorial is equal to 4 into 3 into 2 into 28 factorial. 28 factorial will be cancelled out by 24 factorial. And evaluating these terms, we get some fixed quantity which we can multiply and divide and can be finite. Or we can leave it in the form of combinations or factorial term, that is 32 factorial 4 factorial into 28 factorial, because multiplying this term and dividing is a tacky job. So this is the required number of ways in which 4 can be chosen out of 32. Now let us consider one more example. In this example, in how many ways can a cricket team of 11 be chosen out of a batch of 15 players if there is no restriction of the selection, a particular player is always chosen, and a particular player is never chosen? Now let us consider first case, that is there is no restriction on the selection. The total number of ways of selecting 11 players out of 15 is 15C11, which is equal to 15C 15 minus 11, as we noted NCR is equal to NC n minus R by applying this property, which implies that 15 factorial divided by 4 factorial into 15 minus 4 factorial, which is 11 factorial. Now after solving this, we get 15 into 14 into 13 into 12 into 11 factorial divided by 4 into 3 into 2 into 1 into 11 factorial. 11 factorial will be cancelled out by 11 factorial. By multiplying these terms or dividing, we get 1365. Now second case is that a particular player is always chosen. So if a particular player is always chosen, this means that 10 players are selected out of the remaining 14 players, because one player is always chosen, that is one player is fixed. Remaining, sorry, this is one player. So the required number of ways will be 14C10, which will be equal to 14C 14 minus 10, which is equal to 14 factorial divided by 4 factorial into 4 factorial, which will be equal to, sorry, this will come 10 factorial. Now solving this term, we get 1001. Now let us see third case. Third case, a particular player is never chosen. If a particular player is never chosen, this means that 11 players can be selected out of 14 players. So the required number of ways will be equal to 14C11, which will be equal to 14C3. So applying the formula of combination, that is 14 factorial into 3 factorial into 11 factorial, we get 364. This is the required answer. So we have seen some example based on combination.